Okay, YouTube, as we embark on our trig unit, we're going to be dealing a lot with angles, and most especially angles that we refer to as being in standard position. So in this video, we're going to discuss what angles are, kind of their anatomy, some special angles, special angle classifications, vocabulary, and just some methods. So let's go ahead and start with what an angle is. You'll notice that in this top left corner over here, we have two rays that share a common endpoint. So basically, an angle is two rays with the common endpoint. Recall that a ray is just a line, or at least a piece of a line that starts at an initial point and goes on forever and ever in one direction. So you'll notice with our angle here, the important bits are that we have an initial side, and this is kind of like the beginning side. And then we have a terminal side, which is the ending side. So we have the ending side, and we terminate at the terminal side where the vertex is where they meet. And so one thing I want to kind of point out here is this. You can tell the initial from the terminal side because we always have kind of a from and to arrow that points where we started and where we rotated to. So we rotated in this direction, and you'll notice that we're using a Greek letter here, and the Greek letter is theta. And so we often use Greek letters like theta, alpha, beta, and gamma. Kind of looks like this here. But we use Greek letters to indicate angles. So Greek letters indicate angles. Okay. And so that being mentioned, let's go ahead and skip to what we mean by an angle in standard position. So this is overwhelmingly the type of angle that we'll prefer to deal with. And the reason why is because we agree upon two things. First of all, that the vertex is at the origin. So when we draw or sketch angles in standard position, we always agree that the vertex of the angle is in the origin area of the coordinate system, and also that its initial side always just kind of lies along the positive x-axis. So you'll notice that in both of these angles up here, we have angle alpha here, and then we have this angle theta here. But one rotates clockwise, the other one rotates counterclockwise here. But these are both in standard position just because their vertex is at the origin and their positive x-axis is their initial side. Now, to distinguish between these two here, we could say that this angle alpha is a positive angle, where the angle theta is a negative angle. And I guess I could spell those out for you there, by the way. Alpha, alpha. Theta, this word that I'm saying here, is T-H-E-T-A, theta, the Greek letter theta. But essentially what we want to indicate is that when we spin clockwise, clockwise motion or clockwise rotation is going to indicate a negative angle. And when we have a counterclockwise motion, so we have counterclockwise, we are indicating a positive angle of rotation. So we have a positive angle. Okay. So those things being said, we note that angles rotating counterclockwise are considered to be positive. So we have our positive angle theta, where we have a negative angle alpha here. So angles rotating counterclockwise are considered to be negative, but also that angles in standard position have their terminal sides that lie in quadrants. So that being said, we want to kind of label these quadrants, but remembering that the first quadrant is in the top right section here, where x's and y values, they're all positive. But we go counterclockwise, so we say quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And you'll notice I use Roman numerals because that's often what we use. But we say that every angle that's in standard position must have a terminal side that terminates in one of these quadrants, or at least on an axis. And so we say that all angles terminate in a given quadrant. Okay. So that being said, let's just go ahead and look at a couple other important facts, starting with this one here. When we talk about angles in standard position, we often refer to an angle that is 0 degrees as just kind of staying where it starts, which is the positive x-axis. Rotating counterclockwise or positive fashion, we have 90 degrees, 180 degrees, 270 degrees, and we're going to relabel this 0 degrees as an or 360 degrees. And so we could label these otherwise, but these are pretty basic ways to indicate these directions here, and we refer to these as a quadrant angle or a quadrantal angle. And so when we use the word or vocabulary term quadrantal angle, we are referring to these angles that lie on an axis there. So we say an angle said to be a quadrantal angle lies either on the x or the y axis. So the last thing we're going to do in this video is just kind of classify a few important angles, starting with acute and obtuse. We say that any angle that is an acute angle would be some angle between 0 and 90 degrees. And we say not including 0, not including 90, specifically between them, whereas anything greater than 90 but less than 180, you'll notice that this 180 here is kind of this straight angle you see over on the right, but between this 90 and 180 here, then you would be an obtuse angle, whereas a right angle would be smack dab in between them, and we say that it forms a 90-degree angle here. And last but not least, we say that a full or a half rotation here, not a full rotation, but a half rotation would be a full 180 degrees, and we refer to this as a straight angle. So in the next video, we'll look at how we measure angles, not with degrees, but instead with radians. Cheers.